So we are going to start solving exponential equations. And to do that, we are going to have to use this property. If a to the u equals a to the b, then u equals b. That tells us if we have the same base written once on each side, then the exponents have to be equal. So if I said like 2 to the x equals 2 to the third, that means that x is equal to 3. The key, though, has to be the same base, and it can only be written once on that side. So we can't have multiple terms, we can't have things being multiplied together. All right. So, you did some of these last year, I believe, so maybe it'll be familiar. We're just going to jump right in with examples. And this is all we're doing today, working problems that we can use this property for. So if I said 3 to the x plus 1 equals 81. We can't change the problem. So it's not something where I'm trying to multiply by something on each side. I can't just say, oh, I'm going to take this times 27 and turn it into 81. It has to be mathematically equivalent. I can't change 3. But what is 81 equal to? It's 81 to the first. What about a power of 3? Does 3 to the 4 is 81. So all I did is replace 81 with something it was equivalent to, 3 to the 4. Okay. Now I have a 3 on each side, so my bases are the same. That means the exponents have to be equal. So x plus 1 equals 4, so x is 3. You could always check these by plugging them back in. If you put in 3 plus 1 is 4, 3 to the 4th does equal 81. All right, 2 to the negative x equals 16. I can't change 2, but how could you write 16? Again, we didn't change the problem. 16 and 2 to the 4th are the same number. So then we have a base of 2 on each side. So negative x equals 4. So x is negative 4. All right, let's try another one. What if I said 5 to the x equals 1 over 25. It's really hard to change 5. 25 is 5 to what power? Squared. What would make it go to the bottom? Negative. 5 to the negative 2 is 1 over 25. So that means x is negative 2. All right. What if I said 4 to the 2x plus 1 equals 32. Does 4 to a power equal 32? No. So what can I do? We can take it down to 2. We're going to have to change both of them here. Now this 4 already had an exponent. I'm just going to put that on the outside. I'm only working on the 4 right now. 4 is the same thing as 2 squared. Okay, over here, 32 is 2 to the 5th. So you might have to change both sides. Exponent rules. If you have a power to a power, what do you do with those exponents? Times. So that's 4x plus 2. Now I have a base of 2 on each side, so now I can set my exponents equal. 4x equals 3. So x is 3/4. Can you guys try a couple? Sixteen is 4 squared. Is 8 a power of 4? So what would we do? 2. 8 is 2 to the what power? 3. Okay, 16 is 2 to the 4. All right, so then exponent rules, power to a power, we multiply. So now we have the same base on each side. You can set the exponents equal to one another. And we get 6. And again, you can check it by plugging it back into the original. All right, this one, 9 and 27. What can I do with those? 3. 9 is 3 to the 2nd. 1 over 27 would be 3 to the, okay, power to a power, we multiply. So set the exponents equal. And we get -3 halves. Any questions on those? Let's look at, let's go to this one. Okay, can I take the 4 times 2 right now? Order of operations says we have to do parentheses, exponents before we multiply, right? I can't do 4 to the x power. So I can't multiply these things yet. But when I'm looking at this, we have 3 bases. We have a 4, a 2, and a 16. I could write all of those as powers of what? 2. Okay, 4 is just 2 squared. 2 to the x squared, that's already a power of 2. I don't need to change it. What would we do with 16? So I rewrote the 4 and the 16. Exponent rules. Power to a power, we multiply. So we have 2 to the 2x times 2 to the x squared equals 2 to the 8. Okay, exponent rules. If I am multiplying these, what do we do with our exponents? So that's 2 to the x squared plus 2x. All of that work was to get it so that I had just a single base on each side. So now I have a base of 2 on each side, which means my exponents are equal to one another. So x squared is 2x minus 8. That would factor into x plus 4, x minus 2. We hit -4 and +2. You can check these. We shouldn't be getting answers that don't work here, so if you get the answer, it does work. But you can always double check your math by plugging it back into the original. Any questions? Let's do like 3 or 4 more. All right. Don't panic just because you see an e. That's just my base. So I have an e to the x squared. I have an e to the 3x. How could I rewrite 1 over e squared? So then exponent rules, if these e's are multiplied, we add their exponents. So then we can set our exponents equal to one another. Equal to 0. So multiply 2 and add to -3. And -2 and a -1. So x is 1 and 2. You guys are very quiet today. Is this making sense? I think he is. You look like you are. All right, what would my common base be on these? 5. How would I rewrite the cube root of 5? How would I write 1 over 5? 5 to the -1 power. Negatives, put it on the bottom. Right, so then if I multiply my exponents, I have 5 to the -1/3 x equals 5 to the -x minus 2. So -1/3 x equals negative x minus 2, add over my x, divide by 2/3 or multiply by the reciprocal and we get negative 3. All right, let's do, I have like 3 examples left. I at least want to do one of them, and then if we need more, I'll do the others. This is the one that I definitely want to go through. I can only solve this if I can get a common base. I can't change 5. No other number to a power gives me 5. Which means I have to change the 1. So 1 is the same thing as 5 to what power? 0. Anything to the 0 power is equal to 1. So now we have a common base, and we can solve. Do we need more examples? There is a handout posted on Classrooms, 12 questions. That's your homework, and you have time to get that done now.